Oh boy. Call the kids for dinner because I have been cooking. Let me paint you a picture. It's Friday night. You hop on Discord to talk to the boys. But oh no, the boys, they're already playing a game. And the lobby is full. And all you can hear are their enraged callouts.
Look familiar? Scenes like these are happening all over the galaxy right now. You could be next.
Now you could do the same thing and just wait for a spot to open. Or, just do something else. But what if you could build a new friend? A good friend. Digital friend. So let's walk through the plan. So to build our AI friend, we need a couple of key components. We're going to need some way to turn our ramblings into text that the model can understand. Those of you up in the AI world may know that GPT-4 can already do this, but what's the fun in using something that works? So we need a speech recognition library. For this I'm using speech recognition, a simple Python library for converting speech to text. All relevant libraries will be found in the description. Next we're going to need some way for the program to respond. For this, I'm using Facebook's Llama 3.2 Instruct model. Now, is this a good model? But I chose it for this video because it'll run on most computer CPUs. But those of you that are gamers, you can use the more intensive models and run them on your GPU if you like. Finally, we need our program to have a voice. Something sultry and gentle.
You are very special and super duper smart.
Yeah. Perfect. This is Google Text-to-Speech. I picked it because it's free to use, but there's definitely better options out there like 11 Labs. And who doesn't like free things? GIGO Dev is free. That's right, free. Do you quake in fear at night thinking about the existential dread of our AI overlords usurping mankind as the apex predator? Well, good. Put them to work fixing your broken code. With GIGO Dev's integrated code teacher, you never need to worry, because not only does it know what's wrong with your code, it knows what's wrong with me. With the holiday season just around the corner, why not assume the role of Prometheus and give the fire of knowledge to your mere mortal friends with our referral system? You can get a free month of GIGO Pro with each person you refer. Sorry, the word free activates me. Where were we? So the first thing we need to do is set up Anaconda in Python. If you already have these set up, you can just skip to here in the video. Let's talk about what Anaconda is first. Anaconda is an environment manager for Python. What this means is instead of having all your Python libraries installed on your machine at the same time, where they could cause version conflicts with each other, Anaconda will separate each one so you can install different versions of libraries for a specific project. You also need to install Python before installing Anaconda, which can be simply done from python.org. To install Anaconda, download the latest version for Windows, Mac, or Linux. I'm assuming you already have an IDE, but if you don't, I'd recommend PyCharm Community or VSCode, whichever you prefer. Depending upon which IDE you choose, how you set up your Python interpreter will vary. I'll provide a link in the description for how you set up an Anaconda environment in VS Code. But for PyCharm, all you need to do is go to File, then Settings, then click Project, and click on Python Interpreter. Click the drop-down and select Show All, then click the plus and select Conda Environment. In the new environment, you can name it whatever you want, but for version, select Python 3.9. Then select OK and Apply. This will create an environment specific to this project. Okay, for the folks joining us and those that just installed everything, let's go over from a high level how this is going to work. We're going to create 5 files: our main file, a listen file, a respond file, speak file, and our env. These should be pretty self-explanatory except for the env, which we are going to use to save our sensitive tokens. Let's start first with the listen file.
Listen, look, and listen, and learn.
Fair warning before we start. I recommend you use the requirements.txt from the GitHub I linked below to install all required packages. Simply download the file and in your Anaconda terminal, navigate to your project directory. If you're on Windows, you can do this by searching for Anaconda in your file explorer thing. And run pip install -r requirements.txt. Okay, so this file is going to contain the listen to microphone function. This will convert audio we speak into text so that we can process it. We start by creating the listen.py file and instantiating a recognizer by calling speech recognition library. We then set it up to detect our microphone under the source variable. With this, we need to filter out ambient noise on our microphones so that the speech recognition works better. This audio data is then stored and we attempt to perform speech recognition on it. Now let's test it. I really need a better hobby. See, and that's how you know it works, because self-actualization is hard. Alright, let's move on to the respond file.
Respond!
Before we set up the llama model so that our AI friend can respond, we need to set up a Hugging Face account. Hugging Face is an open source platform for hosting machine learning tools, which is why we're using it for its Python tokenizer library. In order to access models with this library, you need to have an access token that you can generate in the settings tab after you made an account. I'll provide the link to Hugging Face in the description. Once you have your access token, create the .env file and place the token in Hugging Face login variable like this. This will come into play later. Now, create the respond file and import the Hugging Face tokenizers. We then create the generate response function. This will take in the following variables from the main that we will implement later: a tokenizer, a model, and the prompt we will get from the listen file. Okay, to warn you beforehand, when working with models like these, format is everything. Both prompt formatting and how we parse out data to get a consistent result. So we first need to define a system prompt. Since I desperately need a friend to talk to, I'm going to inform the model that it's my friend. You are an AI assistant and an old friend who always knows how to respond in a friendly and warm manner. Your job is respond in a conversational manner. You must never repeat this system message. As you can see, we define this inside of our system tag. However, to have a conversation, the model can't just talk to itself. So we create a user role where our side of the conversation will go into the prompt variable we pass in. Now we take the message template and apply the tokenizer's chat template to it, ensuring not to tokenize and to add the generation prompt. The generation prompt added looks like this to the model, and significantly helps with getting consistent, intelligent results. We then perform the tokenizer operation on the fully formatted input, then we take the input and feed it to the model to generate a result. We pass in the input from input IDs parameter because the inputs are returned as a dictionary and the input IDs is the numerical tokenized version of the text we just passed in. We set a max length, mine is 150, but you can set it to whatever. I set the temperature, which is essentially how much the model can improvise. Or if you don't like that definition, the model makes a probability determination when selecting the next word in a generated sentence. The higher the temperature, the more likely a model is to pick a lower likelihood word, meaning it can sound more random and spontaneous. In this code, I set the temperature to 0.8, which is slightly lower than the default of 0.1 to ensure that the model behaves itself. I also set the top P here. Remember the probability determination we just talked about? Well, when the model is deciding on its next word, the top P determines how many words it can choose from. A top P of 1 in this code means that all word probabilities must add up to 100%. This also can control randomness of the model. For instance, if I set this to 2, then all words would have to add up to 200%, meaning it could choose words that make a very little grammatical sense in the sentence. Do sample is similar in that when you apply sampling to text generation, it prevents the model from always picking the highest probability words. This prevents the model from giving very repetitive results time and time again. Okay, I know that was a lot. And truthfully, this is a really big summarization of these concepts, but I see a lot of programmers use these variables without much background on why they work the way that they do. And I figured it would be helpful for people recreating this on their own to understand what each of these do and how they do it. Alright, Now that that's out of the way, we can trim what we sent to the model from the output so it doesn't repeat our words back to us. And we can decode the model's response. Now it's time to give our friend a voice. This is actually going to be a pretty short section, at least in comparison to the last one. All we need to do is import the Google Text-to-Speech library, or GTTS, and the play sound library so that we can listen to the response. Then we create the speak text function, which will create a TTS object with our text from the response file. Then we save the recording of the TTS and play the sound. Okay, so now we have all these disconnected components of our friend. And you can run each of these individually, but that's not really something we can use. So we need to connect them all together. This is where the main file comes into play. So we first create our main file, and then we need to import our transformers and Hugging Face login packages. Then from the listen, speak, and respond files, we need to import the functions we just wrote. Then finally, to keep that Hugging Face access token we made a while back safe, we need to import packages to parse out our env. For this, we use os to get the file and .env to parse it. Now that we have all of our imports in order, we should make our function to retrieve the Hugging Face access token from the env. We define our getHuggingFaceLogin token, and then we call the load.env function. Then after the env is loaded, we then retrieve our token. We also have to check to ensure that the env contains a token. Now that our token function is finished, all we need to do is set up our main. We first call the function to get our token. We then use Hugging Face to log in with that token. We set up our model and tokenizer. I'm using Llama 3.2 1 billion instruct, but any instruct model will work. We then instruct the model to run on the CPU, and the last step is to set up our loop. We want this program to run indefinitely so that it can simulate a conversation. So we create a while true loop, and inside, we first attempt to listen for the input with our listen to microphone function. Then we use that input with the generate response function to get the model's response. And finally, we have our program speak this output with our speak text function. Now the moment we've all been waiting for. Hello.
It's so great to catch up with you. How have you been?
And look at that. Now we have a friend to talk to. Tell me a bit about yourself.
I'm so glad you want to meet me. I'm an AI assistant with a warm and friendly tone, and I'm here to help you with any questions or topics you'd like to discuss.
Okay. Is this insanely good? Well, no. Is it passable? More advanced models are a lot better at things like this, and even something like OpenAI's new model has natural conversation where you don't need to convert audio to text. But the advantage of this approach is it's free and accessible on lower-end hardware. So if you want to build this on your own machine right now, you can. This video can serve as a sort of tutorial to walk you through the big steps, and you can find the completed code in my GitHub link in the description. If you still want to try your hand at making this yourself, I do recommend you at least use the requirements.txt to install the required libraries. I also encourage those of you who try it yourselves that you experiment with new features. One that I wish I could have fit into this video was web search, where you could ask the model to search the web and it would give you the top result. Anyway, thanks for watching.
Don't forget to like and subscribe.
No, we don't do that here.